Tesla is about to play a new card, replacing lithium with salt in electric vehicle batteries. The sodium-ion battery technology recently announced by CATL can cut costs by 30% and operate reliably even at extreme temperatures as low as -40 degrees Celsius. This is no longer a distant future, the race has already begun, and a salt-powered car could soon be in your driveway. What secrets lie behind the impressive performance of this next-gen salt battery? Before we begin, please help us reach 8,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Model Q, Tesla EVs, and the latest news. Why can sodium-ion batteries reduce charging time to just 5 minutes? One of the recent highlights of sodium-ion batteries is their ability to charge super fast within 5 minutes. Although the exact percentage of charge achievable in such a short time remains unclear, this breakthrough has sparked high expectations. More importantly, real-world performance is measured not only by charging speed but also by energy density, a metric that indicates how many watt-hours each kilogram of battery can store. The higher the energy density, the farther an electric vehicle can travel, and the longer a device can operate without increasing weight or size. Currently, most commercial lithium-ion batteries, the common type used in electric vehicles and smartphones, have an energy density ranging from 200 to 300 watt-hours per kilogram. This means 1 kilogram of battery can power a 20-watt light bulb continuously for about 10 to 15 hours. If battery technology can increase this figure to 500 watt-hours per kilogram or more, the industry will enter a new era. However, according to forecasts, such improvements are expected to occur gradually over the next 10 years rather than overnight. Initially, sodium-ion batteries were considered weaker in performance, reaching only about 130 to 160 watt-hours per kilogram in the first generations. At that level, they were more suited for stationary energy storage systems rather than powering long-range electric vehicles. However, the landscape changed in April 2025 when CATL, the world's largest battery manufacturer, announced the Naxtra series of sodium-ion batteries, achieving up to 175 watt-hours per kilogram. This marked a significant step forward, narrowing the gap with lithium iron phosphate LFP batteries widely used in many current electric vehicle models. Beyond better energy density, Naxtra also demonstrates superior cycle life with over 10,000 charge-discharge cycles and the ability to operate in extremely cold environments down to -40 degrees Celsius without requiring complex heating systems. This shows that sodium-based battery technology is developing much faster than initially expected. Notably, CATL also revealed plans for the next generation of sodium-ion batteries, expected to launch by the end of 2025, aiming to exceed 200 watt-hours per kilogram, bringing performance closer to high-end nickel or lithium-rich batteries. Alongside sodium technology, CATL is vigorously advancing traditional lithium-ion batteries. Recently, they introduced the second-generation Shenzhou battery, a major upgrade from the first generation launched in 2023. This new series continues to use LFP chemistry renowned for safety and cost advantages, but now achieves ultra-fast charging rates close to 12 C, with a maximum charging power exceeding 1.3 megawatts. This enables electric vehicles to gain up to 2.5 kilometers of range in just 1 second of charging. Under ideal conditions, users can recharge more than 520 kilometers in only 5 minutes, a groundbreaking achievement supported by compatible megawatt charging infrastructure. Even more impressive, the Shenzhou Gen 2 battery maintains ultra-fast charging performance in harsh cold weather. At -10 degrees Celsius, it can charge from 5% to 80% in just 15 minutes, a feat few commercial batteries can match. Even when nearly depleted, this battery can deliver output power up to 830 kilowatts, equivalent to over 1,100 horsepower, demonstrating potential for use in high-performance electric vehicles. This is a leap beyond the original Shenzhou, the world's first LFP battery capable of 4C fast charging, allowing vehicles to travel 400 kilometers after only 10 minutes of charging. These advances show that CATL is not only leading sodium battery development, but also continuously pushing the limits of lithium battery charging performance, offering comprehensive solutions for the future of electromobility. However, claims of increasing energy density by 10 or even 100 times should be viewed cautiously. For instance, a 100-fold increase would place sodium batteries at 15,000 to 20,000 watt-hours per kilogram, comparable to or even exceeding the energy density of gasoline, about 12,000 watt-hours per kilogram. Theoretically, such levels are nearly impossible for any current electrochemical battery technology, whether using liquid or solid electrolytes. Even a 10-fold increase to 1,750 watt-hours per kilogram remains far beyond current practical achievements. Therefore, focusing solely on maximum energy density can be misleading. In reality, a battery's effectiveness depends on many other factors such as charge-discharge durability, charging speed, thermal tolerance, safety, cost, and performance under challenging conditions. A battery with 175 watt-hours per kilogram that can charge to 80% in minutes, sustain performance beyond 10,000 cycles, and operate reliably in cold climates without heating systems may be far more valuable than a 300 watt-hours per kilogram battery that overheats easily and degrades quickly. From this perspective, recent advances in sodium-ion battery technology, though still behind in energy density, play a crucial role in changing the game. With lower costs, improving performance, and adaptability to real-world conditions, sodium-ion is steadily emerging as a strong candidate for both energy storage and electric vehicle applications. Once again, please help us reach 8,500 subscribers. This is important for us to stay motivated. Thank you. Why can this sodium-ion battery resist extreme cold? The sodium-ion battery developed by CATL marks a significant milestone as the first mass-produced battery of its kind in the industry, scheduled for production starting December this year. It is designed for compatibility with both hybrid electric vehicles and pure battery electric vehicles, representing a versatile solution for the automotive sector. One of the standout specifications is its energy density reaching 175 watt-hours per kilogram, the highest in the industry for sodium-ion batteries. This high energy density translates into practical benefits. Hybrid vehicles equipped with this battery can achieve an electric-only range exceeding 124 miles, while fully electric vehicles can surpass 310 miles on a single charge. Additionally, the battery supports ultra-fast charging at a rate of 5C, allowing rapid replenishment of energy, coupled with a remarkable cycle life rated at 10,000 charge-discharge cycles. These figures signal durability and convenience that rival or surpass many current lithium-ion solutions. Safety performance is another critical advantage. CATL subjected the battery to rigorous testing protocols, compression from multiple sides, needle puncture, electric drill penetration, and even sawing the battery casing without triggering any fire or explosion incidents. This level of safety is a significant leap beyond conventional lithium-ion batteries, which are prone to thermal runaway under similar stress. Performance at low temperatures is where this sodium-ion battery truly shines. In tests conducted at -22 degrees Fahrenheit, the battery demonstrated the ability to charge from 30% to 80% state of charge within just 30 minutes, while retaining 93% of usable capacity. Remarkably, even when the battery state of charge was as low as 10%, the vehicle could sustain highway speeds of 75 miles per hour. Such resilience under cold stress is nearly impossible for traditional lithium-ion batteries, which often see significant capacity loss and reduced charging speeds in cold weather. The most impressive feat is the battery's continued excellent charge and discharge performance even at an extreme -40 degrees Fahrenheit. At this temperature, the vehicle can maintain highway speeds of 75 miles per hour even when the battery is nearly depleted 0% charge. This capability was previously unthinkable with lithium-ion technology and could redefine the feasibility of electric vehicles in harsh winter climates and cold regions worldwide. These three technological breakthroughs, long driving range nearing or exceeding 1,500 kilometers, ultra-fast charging capability, and exceptional cold weather resistance collectively represent a monumental advancement in electric vehicle technology. Vehicles equipped with this new generation of sodium-ion batteries could present a compelling alternative to hybrid vehicles, providing all-electric range and convenience without the compromises traditionally associated with electric vehicles operating in cold climates. As this technology begins to roll out in production vehicles over the coming months and years, consumers stand to benefit from electric cars that finally eliminate the trade-offs between environmental benefits and everyday convenience. Drivers will no longer have to worry about range limitations, lengthy charging sessions, or diminished performance in winter conditions. Instead, electric mobility will become more practical and accessible. How will sodium-ion batteries impact electric vehicles in the coming years? Although the global electric vehicle (EV) market is experiencing strong growth, the industry still faces significant barriers such as high costs, limited charging infrastructure, and public concerns about driving range. However, recent breakthroughs from CATL, particularly its sodium-ion battery technology, are offering promising solutions to these challenges. By using cheaper raw materials and a simpler structure compared to lithium batteries, this new type of battery has the potential to reduce EV prices and make the supply chain more flexible. Furthermore, the integration of ultra-fast charging technology and a dual electric system into the new battery design helps shorten charging times, improve energy efficiency, and significantly extend vehicle range. This advancement is placing substantial pressure on competitors, especially BYD, currently seen as Tesla's main rival in the Chinese market, which recently launched a battery capable of delivering a 400-kilometer range after just 5 minutes of charging. Tesla, once regarded as the frontrunner in battery technology, is now under pressure to accelerate innovation or risk falling behind. Meanwhile, traditional automakers such as Mercedes-Benz, BMW, and Volkswagen, many of whom are clients of CATL, face a tough decision: either adopt the new Chinese battery technology or invest in developing their own alternatives while risking technological obsolescence. The impact of this new battery technology extends far beyond the automotive sector, reaching into global geopolitics. As tensions between the U.S. and China continue to escalate, especially following former President Donald Trump's imposition of heavy tariffs on Chinese goods, the cost of Chinese-made batteries and EVs entering the U.S. market could rise significantly. What is the future outlook for this battery technology? As the electric vehicle industry surpasses existing technological and performance limits, the future vision becomes clearer than ever: global widespread adoption. In this context, sodium-ion batteries emerge as a strategic choice due to their low cost, flexible manufacturing, and notably stable performance under harsh weather conditions. This could be the key to bringing electric vehicles to millions of consumers in cold climate regions, areas previously considered less friendly to EVs. With recent advancements, EV driving ranges could reach 800, 1,000, or even 1,500 kilometers on a single charge. At the same time, charging speeds have significantly shortened to just a few minutes, eliminating two major barriers: range anxiety and long charging times. As these psychological obstacles are removed and production costs drop sharply thanks to large-scale sodium-ion battery manufacturing, electric vehicles will not only compete with gasoline cars, but also surpass them economically and in convenience. According to Mr. Zhuang, co-chairman of CATL's R&D division, sodium-ion batteries hold a significant cost advantage over traditional lithium-ion technology. Besides reducing costs, these batteries also help decrease dependence on rare minerals, a strategic benefit in a global supply chain increasingly vulnerable to geopolitical fluctuations. Moreover, the long-term sustainability of sodium-ion batteries is drawing special interest from global manufacturers seeking less risky and more deployable solutions. The emergence of new generation EV models designed optimally around advanced battery technologies, particularly dual electrical systems and fast charging, is opening entirely new potentials in vehicle design and operation. These are not mere incremental improvements, but revolutionary changes shaping the future of the entire transportation industry. Forecasts indicate sodium-ion batteries could account for up to 20% of the global EV battery market by 2027, potentially doubling to 40% by 2030, if CATL's development roadmap proceeds as planned. Although this transition may proceed unevenly across regions due to political, market, and policy factors, the direction is unmistakably clear. With current momentum, the new battery technology, especially led by CATL, is acting as a catalyst for a new chapter in the global transportation revolution. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.